Hey guys, welcome back to Barnabas Racer. This week we are going to begin working with motors. So up to this point, we've learned about electricity, how to create complex circuits using breadboarding. We learned about buttons and then even a little bit about coding. So without further ado, let's get started. So as we begin learning about motors, we need to first figure out what motor are we learning about. After all, in robotics there are many types of motors. A few off the top of my head, there are motors called DC motors. DC motors are the simplest motors out there. They are very simple because all you have to do is give it power and it turns on. So it sounds simple enough, right? Now those are perfect for applications where you just need the thing to start moving when there's power, and when you take off the power, make it stop. So you can think about some applications for something like that. Something like a conveyor belt at a grocery store that just turns on and it moves, turns off, it stops. Well, actually, we have a different kind of motor. It's called a servo motor. Now, I can't just stop there because I need to tell you a little bit about servo motors, and actually what's on our car is a special type of servo motor. But let me first talk about servo motors. So servo motors, they differ from DC motors because a servo motor can actually move to a specific position. Okay, so let me explain that. A DC motor, you turn it on and it just starts rolling. This is a wheel, okay? And a DC motor would just then, when it turns on, it would just start rolling and going and going and going and going and going. All right. If you want to go the other way, you can actually change the wiring around and then it'll turn the other way. All right, so that's cool. Now, what about a servo motor? When I say position, what am I talking about? Let's pretend that this, okay, I'm just going to put the screwdriver right here. So this is a spot, an angular position on the tip of the screwdriver. And let's say I want to move it. The tip, you see it's moving. It moved there. And then now it moved there. Okay, now in terms of angles, and this is a little bit of math here, I wonder if you know how many degrees is it to go from here all the way around, back around. So I think maybe it's in geometry, and maybe a little before that you learn about the number of degrees within a full circle. It's 360 degrees. When I was in high school, there was this really popular game called 1080. It was this snowboarding game on N64. And so, there you go. There's geometry right there, because 1080, that's like you're doing a spin. It's not 360. 360 is you're doing one spin in the air. This is like the half pipe on in snowboarding, like X Games on ESPN, if you guys ever seen that. So 360 is one spin in the air. 720 would be two spins in the air. 1080 would be three spins in the air. So that's kind of the point of the game, to do super cool tricks, and 1080 was one of those like amazing tricks. Okay, anyway, so I always like to connect life with kind of what we're learning. So you learn about degrees in robotics. You also learn about degrees in snowboarding. Okay, so position. So now we know a little bit about degrees and positioning. So the thing about a servo motor is, if you want to turn, like let's go back to look at our screwdriver head. I'm going to go here, this position, and then this position, and then this position. See, as DC motor, it's really hard to do that because you just turn it on and it just spins and keeps going forever. But if I want to go back and forth like this, and it really matters, like I have to go here, and then it really matters that I get to here, exactly here, and then go back and then go exactly there. If you want to do that, servo motor is the one that you want to use. All right, so that's some context about DC motors and servo motors, but what about continuous servo motors? Now, continuous servo motor is a combination of a DC motor and a servo motor. So it is a servo motor that can actually be used like a DC motor. All right, so let's see how that works. I got my whiteboard here. Okay, we're going to give this a shot. So typically a servo motor, I talked about the positioning thing, can go a half circle, so that's 0 to 180 degrees. Now, this is how you would program a servo motor. So typically a servo motor, the ones that we use in other projects and probably the most common servo motors out there, it can only move half a circle. So not the whole like 360 or 720 or 1080 thing I was talking about the snowboarding. It can only move half. So it can only go back and forth. So that's like a something like a windshield wiper, right? Back and forth. Now, that's not going to be very helpful for a car, right? Because imagine a wheel is just going back and forth. That's not going to do much because it can't really move. You just be going back and forth. So a continuous servo motor, what that does is that you use the same 0 to 180 degree controls, but it's actually able to act like a DC motor. Okay, so this is how I'm going to explain it. First thing, you have 0, 180. What's 180 divided by 2, or half of this? Right here is 90 degrees. Okay, so this is what's going to happen. If you say 0 degrees, so let's say when you start controlling your motor, if you tell it to go to 0 degrees, it's going to go full speed clockwise. Okay, so it's just going to keep spinning clockwise. If you put 180, it's going to go full speed counterclockwise, okay? Or it's going to be the other way. So if I do 0 degrees, if I program 0 degrees on my continuous servo, it's going to keep going full speed one way. If I put 180, it's going to go full speed the other way, and you might be thinking, well, how do I stop it? It's in the middle. 90 degrees. Stop. Okay? Now, you might be wondering, why is it so complicated? Why don't you just use a DC motor instead of this continuous servo? And let me write continuous servo, just so we're clear. Why are we using a continuous servo? Well, the reason why is that DC motors are super easy to control, but if you want to be able to easily make a DC motor go forward and backward, you actually need to add something called the DC driver, which is another piece of electronic hardware. So if you actually use a continuous servo, though, the wiring gets a lot simpler, and then the control is a little bit more complicated, but we can take care of that on the code side inside the Arduino. All right, so the main reason why that we're using a continuous servo is to ease the wiring of the Barnabas Racer. If we used to use a DC motor for the Barnabas Racer, but we found that having that extra piece of electronic hardware, it just added more complexity that we really don't need to worry about in this class. All right, so now that we have some context about the continuous servo, let's go ahead and wire it up and then try some programming. All right, guys, so now we have some context regarding how a servo motor works, continuous servo motor works. Now we got to figure out how to wire it to our Arduino hardware that we call Barnabas Noggin. Okay, so let's first look at our servo motors. Here's 1, and here's 2. Okay, so everyone should have 2 servo motors. I'm just going to worry about one of them for now, okay? So I want you to look at here. Let me get some good view there, okay? If you look at this cable, it's got 3 colors. We've got brown, red, and orange. All right, brown is going to be connected to ground. Red needs to be connected to 5V or 5 volts. And then the orange The orange color, that's called our signal color. So the signal is going to be connected to a pin number on our Arduino so that we can control it. Okay, so we got brown for power, red for 5V, brown for ground, red for 5V, and then we've got the orange for the signal. Now, we could use these. We have these pin cables. If you remember these cables here, this yellow one here, those can stick straight into here and make connections to the Arduino. But rather than that, we also have these headers right here. Right here. Let me make sure you see it here. There's actually 4 of them. 1, 2, 3, and 4. Okay. Now, what they say here, they say Servo 3, Servo 9, Servo 10, and Servo 11. Okay. So the reason that we have these here is they're connectors for the servo motors. So here's all you have to do. You take one of these, all right, and then you see the brown one, you put it in, and you want to make sure that the brown wire is going to be facing the feet, okay? The brown wire needs to be facing the feet, and then the orange wire is then facing up here. Okay, you don't want to get it flipped. If I did it this way, you see how that's flipped from what else? See, now the brown is up here and then the orange is facing down there. We don't want that. So first make sure your brown is facing the feet. Okay, I'm gonna kind of turn it this way. Now you want to find Servo 10. Servo 10 is down here. So plug in Servo 10. You match it up so that the three sockets go in the 3 spikes like that. I'm gonna show you guys like this, and then you see how the brown is facing down. So that's in Servo 10. All right, and then you take your other motor. Same thing, brown is facing down, and you go to Servo 11, which is right next to it. Servo 11. Let me move these out of the way. Okay? It's going to look like this. Okay, here's the other side just so you can see. Okay, so now we got Servo 10, Servo 11. So at this point, looks like this. Okay, our wires, they are wired in. That was easy. All right, so now to test, we've got these 2 wheels. Okay, we're not going to screw it in yet. What I want to do is just snap it in like that. It's going to be kind of loose. That's okay. Like it can pop off. I don't want to screw it in yet because we're going to do some testing with this before we actually put it into our car. Okay, so we'll just put it here. It's okay if it's kind of loose, and then we'll also do it with this one right here. All right, so we've got 2 wheels. We've got it all plugged in here. Let's do some coding, and then we're going to do some experimentation and see if we can get these guys moving. All right, guys, let's go ahead and get started in trying to get our motors to turn on. So what I've done here is I plugged in the USB here. Now your USB cable may be blue colored, no problem. Whatever it is, that's as long as we plug it in, the other side goes into the computer. All right. And let's see here. On my coding side, I want to make sure that I have my tools, nano, old bootloader, and then also my COM here selected. Again, if you're using a Chromebook or Mac, this is going to look a little bit different. Just as a reminder. Okay, now going back to our hardware here. Notice here that I've plugged in this. We have the 9-volt battery, and that goes into this special connector that connects into here. okay? Now, the reason I've done that is because we're using these pin headers right here for the motors. Now, these pin headers cannot get power unless you have this battery plugged in, okay? So now, one caveat, if you have a newer board, you may not need to plug this in order to get the motors to work. I have an older revision of the board right here, so I need to have this battery. So I would give it a try with the one that you have. You may be able to get the motors to move without this as well. That'd actually be even better, because what happens is that this battery, if you have it plugged in a lot, it drains pretty quickly. So if you can test it without the battery and just get power from the USB, even better. So up to you guys. If you're not sure, you can always just keep this in there, but just remember that your battery may drain if you leave this in for long extended periods of time. Okay, enough about that. Let's go ahead and start coding. All right, so here's our void and setup loops. I'm just starting a new program here. So what we want to do is first we want to get our motors to get moving. So what we want to do first is say hashtag include. We have to put in a special library called the Servo library to control our servo motors. So let's do that. You do this less than sign servo dot h. You see it became orange. That's a good sign. All right, include servo. Now, going back here, we want to make two servo objects. So I'm going to say servo, and I'm going to say motor A, semicolon, servo motor B. All right, so we got two motors. And then in this setup now, I want to say motor A dot attach, and we're going to attach the pin number. Now, if you remember when we put these two in, we picked servo 10 and servo 11. All right, so motor A, I'm going to say it's going to be 10. 10. And motor B is going to be 11. All right, so now we've attached the servo motor objects, A to 10 and servo motor B to 11. Now we can control them. All right, so the first thing I want to do is I want to make sure that I can program my motors to stop. And so when I program stop, to make sure that it doesn't move. So what I'm going to do now is in our loop, motor A dot write, and inside, oops, let's do that. Inside right here, that's where we want to put in the angle. Now, if you remember, 90 degrees should make your motor stop. So I'm going to do 90, and I don't know which one. Let me see which one. This one here is 10. So this one, okay, this goes, this one here is 10. So if I program this motor should not move. We'll see. So I'm going to upload now. Let's see what happens. Oh, this little screen, just click save. That's fine. It's done. Okay, so I'm done uploading, but look, is it not moving? It's actually moving. Okay, so here's something that we got to learn. We got to learn about calibration. So these motors, like life, they're not perfect, but like life, we can always make adjustments. So in my code, I said 90. So that means theoretically this motor should not be moving, because I just taught you guys earlier that 90 degrees should stop the motor. Well, this motor, he just needs to be adjusted. So when we get a screwdriver, you probably have a little blue screwdriver that is in there, so that would work. And if you turn this over, you're gonna see there's this little screw here. Now that's like a dial, and it helps adjust. So right now we need to adjust the screws so that this stops. So I'm gonna put this in here. You don't want to turn too hard. You want to break it. So it's actually not very hard to turn at all. So you don't have to put that much pressure. But watch, I'm going to turn. Okay, so you see how it's getting worse, right? It's getting further away from stop. It's faster. I'll keep turning. Okay, it's even faster now. Okay, this tells me I'm going the wrong direction. So let me go back the other direction and see it stopping. and then keep going, and then I'm good. Now, just so you know, if I kept going that same direction, watch. It's actually turning the other way, and I keep going, and it's just kind of messed up. So just do it really slowly. I'm good. Okay, so take some little fine motor skills. Just do it slowly and kind of find the right spot, and it'll stop. Okay, so that's number 10. Let me do this one, number 11. So I'm gonna say motor B dot write 90 upload. Oh, motor B actually does not need to be calibrated. He's perfect. That's cool. Okay, so now I'm gonna move this out of the way. I'm gonna go ahead and tape this down onto here so that we can start doing some tests and they won't go flying over the place. So I got these sticky foams. You could try it with just some masking tape or something, but I'm gonna use these sticky foams. Okay, it's just temporary for our testing. I'll put one here. I'm gonna get another one here. Here. Put it right here. Okay. Now you notice how I didn't do this. I didn't do this until I calibrated, right? Because look, I can't get to the screw underneath there. It's stuck on there now. So you always want to first calibrate it, then put it on. Okay. So let's try this out now. Let's have some fun. Let's turn both motors 180. And then they should both start moving. Let's see. Upload. Cool. They're both turning the same direction. See, they're both going this way. Now let's turn them both the other way and watch it change direction. Very cool. All right. Now, what if I wanted to go one way and then the other way in one program? So I'm going to go both 0. Then I'm going to delay 1000. So I'm going to do it for 1000. Then I'm going to stop them both. So that's going to stop both. And then I'm going to stop for 1000. And then I'm going to go the other way. And I'm going to wait for 1000. Okay, let's upload this, see what happens. Okay, so it goes. I think it's working. Nice. Okay, I'm gonna go ahead and stop this now. Erase that. This will stop it. All right. So now, where I want to end today is to be able to program our motor to move only when I press the button on the breadboard. So let's see if we can remember how to do that. All right, first thing we got to remember is that the button is on pin number 2. So let's go ahead and set up pin mode 2, and it's going to be an input. Oh, it should be 2, comma input. All right. And then we have to say the conditional thing. If digital read 2, because we're looking at what is the status of pin 2. And I want to make it that if I push the button, it moves. So the first thing I want to remember, if I push the button, is digital 2 low or high? Hopefully you guys got it without me telling you. If you push the button, it allows electricity to go down to ground, which is low. Okay. And I'll put a comment. This is what happens when you press the button. Okay. Else, here we go. This is what happens when you don't press the button. Okay. So, you know what? Let's just do like some review with the light, and then we'll do the motors. Kind of a step-by-step thing. All right, so we have the light. Let's set up the light. Pin mode 7 output. Okay. So when I press the button, let's turn the light high or on. Same thing. Digital right 7, comma high. That will turn it on. And if I don't press the button, digital right 7, the opposite of high is low. Let us upload this to make sure our button circuit still works. Okay, I'm uploading. Okay, so right now, if I press the button, the light should turn on, and it does. Press on, let go, off. Press on, let go, off. Okay, so that was just a quick review from last week. Now let's input the motor stuff. So we got digital. Wait, hold on. Let's make sure we know what we're doing here. Okay, if we push the button, I want to move motor A. So motor A is motor A dot right. Let's just pick the 0 direction. And if I don't press the button, I want to make sure that we turn it off. Okay. Which is stopped. I'm going to get rid of this. And actually, I'm going to move these two up here. Okay, so what that does is that when I first start off, I want to make sure my wheels are turned off. That's actually a good idea. It's like when you first try in your car, you want to make sure you don't just all of a sudden start driving, right? So let's just make sure we put this here in the setup. Remember, setup just runs one time. So after it sets up your motor A and B, it makes sure it's stopped, and then it runs this code. Okay, so that will make sure that motor B and A are stopped. Let's see if this works. I'm gonna push that. Okay, moment of truth. Let's press the button. Hopefully the light and the motor A will turn on. It works. Amazing. Amazing. Okay, now let's get both motors moving. Easy, right? Add a motor B dot right. Add a motor B dot right here, and then the first one was 90. This is to stop it. Okay, so now they should both go. Nice. We are doing great. Okay, so now let's go the next step here. Let's make it so that when I press the button, it's gonna move for 1 second and then stop. That should be easy, I think. Let's see. So when I press the button, that's this part of code, I'm gonna move forward for 1 second. And then stop. So I think this should work. Let's see. Okay, so now I'm just gonna push it and let go. I'm gonna push and let go, watch. Beautiful. Now if I wanna move for 2 seconds, just change that to 2000, here we go. Okay, now you might be wondering, like, Coach Ed, you have motor A, motor B, 0, 0. That means to move. I get it. Then you put a delay 2000. I get that, but then you didn't tell it to stop right after. So why does it work? Well, that's what I was thinking at first too, but then if we look at the code and see what happens, after it finishes executing delay 2000, what happens? It jumps out, jumps to here, and there's no code here, and then so it's just going to go back here to the beginning and then execute. So if I've already let go of the button, then it's going to say, well, it's not push, so then it's going to go down here, and then what happens? It turns off. So actually, I don't need to put the off commands right here, because actually what's going to happen is after it executes, it's going to jump out, and then right away jump back down here, and this code executes to turn it off. So just a little tip, if you know how the code executes, you're going to be able to save extra commands, save you some work. Okay, so now let's say I want my car to move forward when I press it, I want it to move forward for 2 seconds and then move backwards for 2 seconds. So let's go ahead and keep editing my code here. So when I push, I'm gonna go forward for 2 seconds. Oh, actually I should stop, right? So let's stop. So that stops them both. And I want to stop for 2 seconds, let's say. Then I need to move it the other way. Okay. And I'm going to delay. Okay, let's see what that does. Okay, I'm just going to push it once when it's ready. Okay. Okay, that looks easy enough. All right, so here's the other thing I want to do. While we're here, there's also something you can do. You can actually make it go half speed. You might be wondering, how does it do it? Well, if 90 is stop, 0 is full speed one way, and 180 is full speed the other way, what about all those numbers in between? So if you do a number between 0 and 90, so what's half of 0 and 90? The in-between is 45. If you do 45, it's going to be half speed one way. And if you do the other number, which is halfway between 90 and 180, which is 135, it'll go half speed the other way. So let's experiment with that. So I'm going to say, I'm going to change my program here. Okay, I'm going to say 0, 2000. Then I'm going to go 45. Okay, and then I'm going to go 90. All right. So what's going to happen is going to go full speed one way, then half speed the same way, and then stop. Let's see. Let's try this. Could you tell the difference? I couldn't really tell the difference. So sometimes life's not perfect. Let's go a little bit higher. Now here's the thing. If the closer that you move this number right here to 90, the closer it is to stopping. So what if I put 60 and 60? Maybe then I'll be able to see a difference. Wait for this to upload. Oh, you saw it. I could hear it slow down. Okay, so you see it's an inexact thing. I said it's half speed at 45. Actually, that's not correct. The scene 45 didn't really do much. So But 60 became slower. Let's say if I change it to 80, and 80 should be even slower, because again, 80 is really close to 90 at this point, and 90 is to stop, right? So let's upload that. Okay, so 80 is like, this one is pretty slow, but then this one's totally stopped. So this is where you can start seeing, see, there's differences between my motors. So I'm going to have to experiment to get them to go the same speed. And so that's a reality of robotics. Your motors, all your hardware, your hardware here, and then your mechanics here, they might not all behave the same, but we can fix it. We can adjust it through code. So this one was going at 80. For 80, this one was going slowly, but this one was like basically stopped. So let's see which one this one is. This one's connected to number 10. Okay, so Servo 10 for some reason doesn't like 80 because it's basically stopped at 80. So let me, Servo 10 is motor A. So motor A, 80 is too slow. So I'm gonna try 70 for motor A, and maybe they can start behaving similarly. We'll see. Okay, you see that really helped. Now I want you to notice this one's a little bit faster. Slightly faster. So 70 is a little bit too fast. So let's see, if I go higher, if I go closer to 90, the motor A will slow down. So I need to slow it down a little bit, so I need to go up. So I'm going to try 75. Maybe that's the magic number. Okay. Try again. Okay, see how this one stopped early? It means 75 is a little bit too close to stopping. So 75 is not what we want. Let's try 74. I know you're probably like, well, this is crazy. Well, this is really going to help you, because when you start actually putting these onto this thing for the car, and you're trying to go trying to adjust so that the car can go straight and to make turns, you're gonna have to be starting to do that kind of thing on this. So it's important to experience this kind of debugging, troubleshooting before we put it onto the car. All right, so I put 74. I think I uploaded. Let's just make sure. Okay. Okay, you see how this one, it like almost stopped. Let's. Yeah, it's like trying to get there almost. So I think 74 is also still too slow. Let's speed it up slightly. 73 for motor A. I think this will do it. I would guess that this would do it. Let's see. That is pretty good. But you know what? I think it can be even better. Let's try 72. Yes. So 80 and 72. That's the numbers to get this to work. So guys, so keep in mind that your motors will not act just like mine. And then also it depends on how you calibrate it with the screw too. That could also affect it. So moving forward, so this week, I would like you to experiment with the motors. Try to get them to move maybe slowly at the same speed one way and also the other way. Try to get them to move fast. The important thing is make sure that you can at least get it to react to the button and they're able to go back and forth. The more experimenting you can do in terms of getting the wheels to move at the same speed at slower speed and high speeds, that's going to better prepare you for next week in the following weeks when we start actually driving with these motors. All right, so I think that's it for today. There's a lot more to come. Hopefully you guys have fun. Also, I know I said it already. I want to make sure I say it twice. If these motors aren't moving at all and you're like, I totally connected this, like these cables, into the right place and everything, make sure that you have this plugged in. And then also, caveat, again, I said it, I'm going to say it again. You might not need to plug in this battery if you have a newer board. Okay? All right. So that is all I have for you. Have fun, and if you have any questions, feel free to always reach out. Hopefully you guys had a good time with that. So today we learned about servo motors. I also gave you some context about DC motors, and then told you why we need these continuous servos, these special servos for our project. We also learned about coding, learning about the servo library to make sure we include that so that we can control it. And I even threw in the half speed, how to reduce the speed of your servo motors, and we did troubleshooting. Really hone in this week, guys. The more time you invest in getting comfortable with these servo motors, the easier your life's going to be when we put them onto the car and start doing navigation challenges. So go ahead, remember the words that Coach Ed said for this week, and persevere, guys. Do not give up. It may get frustrating because you may be saying the code doesn't match what my robot is doing. Part of the process, guys, part of being a great engineer is being able to persevere and to troubleshoot, to take a breath, and then figure it out, okay? So I'm telling you ahead of time, it's not gonna be easy, but it's okay. This is all part of the process, guys. Trust me, hang in there. So that's it for this week. I will see you next time.